Alright, now I want to look at a set of curves called the Rose curves. Again, I'm going to start here at r equals sine t, and then say, I want to adjust the period. So I want to change, instead of sine of t, I want to look at the sine of 2t. Now before I do that, think about what would happen to this red graph here if I change that to a 2t. Well, you're going to cut the period in half. So from 0 to 2 pi, I ought to see two cycles. It ought to go up, down, up, down, up. Right? Two cycles I should see there. Okay. Now, I think that's what I saw. Now, what happened to the polar graph here? Well, think about what this is telling us here. As theta keeps getting bigger and bigger and bigger, the radius is going to start at 0. It's going to climb up to 1. It's going to come back down to 0. All of that while theta went from 0 to pi over 2. As theta goes from 0 to pi over 2, I went from a radius of 0 out to a radius of 1, back to a radius of 0. Right? That's right there. I'm looking in the direction of pi over 2 right now. Now, as I start looking into the second quadrant, r starts becoming negative, going down to -1, coming back to 0. Pi is right here. So as I'm looking through that second quadrant, I'm actually going to be plotting behind me in the fourth quadrant. Right? Looking into the second quadrant, plotting behind me, all the way down to -1 right there, and then coming back to 0. Oops, I missed it just by a little, but looking in the direction of pi, the radius would be 0. Now as I look into the third quadrant, the radius is positive again, growing to be +1, coming back to being 0. Okay. And then in the fourth quadrant, r is going to be negative again, and so I'll be plotting behind me back in the second quadrant. Right? One of the things I see over here is I see 4 loops. I see a loop that starts at 0, r is 0, goes away, comes back to 0. That's a big positive loop. Then you have this big negative loop here. R is 0, back to r is 0. And then another loop. Right? Anytime you start with r is 0, go away, and then come back again, you've got a loop. So I see 4 loops from the time I do one cycle, 0 to 2 pi. And sure enough, that's what I see there. I see a positive loop right there in the first quadrant, a negative loop, another positive loop, and another negative loop. And I have what's called a 4-petaled rose. I get it from r equals sine 2 theta. If I did cosine 2 theta, it looks very similar, except that rather than starting with 0, I'm starting at the highest point. I'm starting out at the end of the petal. So there's a positive petal, there's a negative petal, there's a positive petal, and a negative petal. And that's also a 4-petaled rose, r equals cosine 2 theta. Okay. I'm going to switch back to sine. What if I made this a 3? Right? Well, before I do it, let's think. What would happen over here? From 0 to 2 pi, I should actually see 3 cycles of the sine curve, which means I should see 3 bumps going upward and 3 bumps going downward, which might lead me to expect 6 petals over there. Let's see what we get. Change that to a 3. Yep, I got 3 up and 3 down. But what happened over here? There's my positive, negative, positive, negative. Interesting thing happening here in that the positive petals or the negative petals are lying right smack dab on top of positive petals that were already drawn. So though I would expect to see 6 petals here, I only see 3. Actually, we've already seen that phenomenon, because when this was a 1 right here, we should have had 2 petals. We should have had one big positive one and one big negative one, but they ended up right smack dab on top of each other. There's the big positive one, and then it turns into a big negative one. Right? Yes, yes. So anyway, there's not a 6-petaled rose. That actually has only 3. Let's see what happens when I change that to a 4. Right? Again, I think the red graph is predictable. The red graph down here, you're going to have 4 cycles, so 4 positive loops and 4 negative loops. Is that what really happens? Now over here, actually, I do see all 8. 4 positives, 4 negatives. Here we go. There's a positive, there's a negative, positive, negative, positive there, negative, so on. You see all 8 petals, 4 of them positive with positive values of R and 4 of them with negative values of R. An 8-petaled rose. Quick thing here. Looking back at that 3, I can actually see all 6 of them. If I do like I did with the Limachon and just shift it up a little bit, if I say plus 0.2, right, my positive petals just got a little bigger and my negative petals just got a little smaller, and I can actually see all of the 6 petals there now. I have long said that I do math so that I can draw pretty pictures. And this right here to me is getting at that point. I mean, I've got this really nice looking curve with the inner loops, and I could print that out. I could fill it in, with a couple different colors here and there. Actually, I'd probably do that on a computer, not by hand. But the ability to draw these curves, I can't do it by hand. You've seen my handwriting; it's not that good. But my math is. I can draw these curves because I can do the math. I can figure out the formulas. Anyway, there you go. You can see all 6 petals there. Let's go back to having no shift to this. All right. Anyway, it turns out that when you have an odd number in here, the positive petals and the negative petals line up on top of each other, and so you have, if this is 5, I see 5 loops. There should be 10, but the positives and negatives are on top of each other. If I go with an even number in there, then I end up with exactly the same number of petals as I should think. I have twice 8, so 16. There's going to be 8 positives and 8 negatives, and it starts getting a little crowded in there. But this is called a 16-petaled rose. Actually, I think it looks more like a daisy. Anyway, so there's your rose curves. All you're doing is you're taking your sine curve or your cosine curve and increasing the frequency, right? Cutting the amplitude down, not the amplitude, the period down, and you're seeing multiple loops. Every single time you go from R equals 0, away from 0, back to 0, you've just made a loop. Right? I see 8 positive loops, I see 8 negative loops, for a total of 16 loops there. Okay? Rose curves.